And then the simple storage service S3 came along soon after. So that's the evolution. And after Amazon, Google came around, Microsoft, Azure came along, and there's so many other cloud providers. We'll briefly talk about them later in the session. And soon the cloud market began to grow, and it's as of I mean 2013 numbers. If you talk about, like, it's around 78 billion pounds, and then moved to 100 billion now. So Amazon leads the cloud market. Amazon, it's around 130 billion as of Q4 2020. And some other leading players are AWS, which is Amazon Web Services, and then you have Azure, and then you have Google Cloud, and so on. So as of 2020, you have like 130 billion in revenue. So I mean, these are all fine, but why would you want to learn cloud, or why would you want to know more about cloud? So how cloud is beneficial to businesses, and then what does it provide? So the first one important is services on demand. If you recall the days, if you want to install any service or whatever, you need to procure the machines, you need to get the people lined up and go through the installation process. Think about you trying to set up an email server, right? You want to provide email to your employees. And what was happening before? You have to get your machines, powerful machines, and then install the mail server, and then configure it, and then provide this email to all the employees to make the entries and so on. So that's how you to get services. But now, how do you do it? Because most of the services, any kind of service that you want, are already available on cloud. Like, let's say, the mail service is a good example. You can go to talk to Google, and then they'll provide an email service just for your company. Same with Azure and so on. Easy access and agility. Now, one of the beautiful thing about cloud is that you can access it from anywhere, right? All you need to do is internet connection, and then a tablet or even a laptop that will provide you easy access, and it's very agile. So what does agility mean? And kind of an easy access, and even if the service gets modified and it doesn't really change much from the user's point of view. Elasticity and auto scaling. So if you recall, if you are not on cloud, remember your resources are not elastic. So what elasticity really means is that your resources will expand to meet the demand. Now this wasn't there before, right? Now you have elasticity, and then you can auto scale your resources. Cheaper and better ROI. So are the resources really cheap in the cloud? Probably yes, but it will definitely get better return on investment, because think about email server. You don't have to maintain it. Everything is done on the cloud. And think about the administrative stuff that are required if you have to maintain everything yourself. So all this will vanish, right? And it's highly secure. The service, because it's on the cloud, Google or Azure and AWS, they make sure that your services are very secure. In fact, security was one of the issues when cloud came along. But now your resources on the cloud are very secure. Global network of resources. Now, one of the things that is very good about cloud is that almost every cloud provider that's out there has resources spread out across continents. So you have resources sitting in Japan, and you can access it locally from within Japan, or pretty much every continent has got resources. Like Google itself has got close to 32 regions, as they call it, spread around across the world. So those in India can actually access resources that are available in India. So that's a very important thing. Easy backup and recovery. Now remember one of the days when you had to back up your software or back up your data and then be able to recover it. That was a very tough job because it was time consuming and you did not have an automatic backup and automatic recovery. So now with cloud, you can achieve this very easily. High availability. What's high availability? So your resources are available 24/7, right? So 24/7, 365 days a year, and they're all available. So there's nothing like somebody will power off or power on your resources. Okay, they're global. That's what we call high availability. And remember when we talked about elasticity and auto scaling? Yeah, that's also in a way highly contributes to high availability because what happens if you are too much lot of demand for your application? Okay, there are too many customers logging onto your web page. So would your application crash? Because it's be able to automate or provide denial of service. So there's no concept of denial of service because okay, I'm busy, I cannot do it. So all that would vanish, right? And move from capex to opex. And this is very important because in the cloud you don't have to make any upfront investment in capital expenses because everything is operational. So pay as you use, right? Think about buying a car for yourself versus uh, using Uber. Uber is kind of whenever you want you can use it. Capex is more. Think about the analogy is more like you have a car in case you have. I mean, sometimes your capex can help you, but not always. I mean, think about the farmers, and they need to hire. They need to do harvesting. So they don't buy the machinery; instead they rent it out. So buying machinery is more like capex, and renting them is more like opex, right? So that's precisely what is happening in the cloud. Okay. So there are still some challenges in the cloud. Security and privacy is a concern because if you think about what the situation was before when cloud came along, nobody believed that cloud is secure. Okay. So, but that is changing. And privacy is another thing. There are always this question like, what happens to my data? What happens? Would I lose my data? Or would somebody snoop on my data? I mean, you never had those privacy concerns when if your data was local. But now that data is in the cloud, uh, you could lose the data and the data could fall into somebody's hands. Now, privacy is still a concern, but obviously companies are working towards improving privacy so that the user's data is protected. And cloud also gives you the mechanism to encrypt your data. It's called encryption at rest. So as long as the data is in the cloud and you can have your own encryption key to encrypt the data. And even if you lose the data or if the data falls into somebody's hands, they can't do much with it. So so second privacy is changing now. So it soon won't be that big of a challenge. Okay. On-prem to keep data secure. So sometimes, like think of the hospitals, okay, or stock market. Sometimes they don't want to keep the data in the cloud. They want to keep it themselves. So that's how do you bring these things into the cloud? So that's again a challenge. Now, very low latency requirements. Now, uh, sometimes you have very low latency requirements. In which case, you may want to have application localized. I mean, application running on servers within your office, right? So, for very low latency requirements, you may choose to not go to the cloud. Government regulation is another thing that can pose a challenge to migration to the cloud because sometimes the governments, let's say in Germany, Japan, they would insist that all the cloud data pertaining to the native population, like the Japanese, should stay within the country. Now, what if the cloud provider doesn't have resources to host all these in the country. So then that becomes kind of a challenge. Portability. So again, not all applications are portable to the cloud, and again, this ties up with proprietary systems where some proprietary systems cannot just move into the cloud. So they have their own software and the systems that they need to be on-prem. So cloud service models. So we talked about the cloud service models, the SaaS, the PaaS, and infrastructure service. So SaaS, a good example would be your Gmail and Salesforce. So predominantly, if you are using SaaS, you are probably an end user, right? So Gmail is a good example of SaaS. Zoom is, and then you have PaaS, platform as service. Okay, so that's more like I want a platform like Heroku, Cloud Foundry. So mostly you have software developers working there on the platform as service. And you have infrastructure service. Now, infrastructure is something, if you want to remember what infrastructure service is essentially like, I want 10 machines, network, several private network, and with so and so features. That's it. Okay, so that's called infrastructure service. When you think of infrastructure, you primarily talk about compute resources and storage, and then networking. So these three constitute infrastructure service. Now, above that we have platform as service. A good example is like, hey, I want a database, Oracle database server. So that is platform as service. So when you request for it, what the cloud provider would do is the cloud provider would launch a virtual machine and install your your database server and then gives it to you. Okay, so that's yeah, again, so software service is a software licensing delivery model in which software is licensed on a subscription basis and is centrally hosted. It's mostly dealt by end users and consumers. Again, platform service, we get third-party provider delivers hardware and software tools to users over the internet. And infrastructure service, when you think of infrastructure service, is a cloud computing service where enterprise rent or lease servers for compute, network, and storage. Now, when you think of AWS, Google Platform, Microsoft, they are predominantly IaaS, although they do PaaS and SaaS too, but predominantly that's what their main job is. So, what facilitated cloud? I mean, cloud did not come by itself, right? Something happened. So there was some excitement in the industry, and so then cloud became popular. So how did it? What facilitated cloud exactly? So one of the key technologies that facilitated cloud is virtualization. So when you think of virtualization, primarily it's compute, as in virtual machines. So when you think of virtual machines, that's precisely what compute virtualization is. And it is managed by a software called hypervisors. Now, as you get into the cloud more, you will keep listening to these terms a lot. So when you think of hypervisors, it's compute hypervisor, compute virtualization. Now, you have storage virtualization too. What is that? It's called software-defined storage. So what does storage virtualization mean? It's essentially, it's a concept of how you achieve high redundancy, low latency, highly redundant, fault tolerant storage software. Like for example, the storage in your laptop, it's not what do you call? I mean, there's no storage virtualization, but think about how do you want to implement storage virtualization so that it's highly available, and if you accidentally delete, you should be able to recover through some mechanism. So all that constitutes what software-defined storage is. Enabled multi-tenancy. So what does multi-tenancy actually mean? When you think about a single hardware being shared by multiple tenants, right? Now imagine a large building and there are apartments. So they are called tenants in some way and they are independent. Okay. But in logical world, nobody knows who else is living in the building. You think you are the only one living in the building. That's because it's very secure and isolated. The concept of virtualization that provides isolation. That's what enables multi-tenancy. And then again, now everything is getting virtualized, right? So obviously the next thing is your networking got virtualized. So you have Open vSwitch, which is essentially L2 virtualization. It's implementation of L2 virtualization. And then you have virtual switches and routers. There's network function virtualization. Now all these virtualization, why do you even need it? I mean, somebody would ask, why do you even need it? Because now we are able to uh, uh, achieve more with the same hardware, right? Your hardware stays the same, but you can extract more juice out of it. Correct? Okay. And then containers and Kubernetes. This is like a recent one. Recently, pretty much the last 5-6 years, almost every application is getting containerized. And Kubernetes is helping achieve that. And cloud native. Cloud native is a new term. Think about how do you manage, how do you develop applications so that they transfer easily from one cloud to another. They use consistent tools, consistent development practices. So that's what cloud native to the cloud. So that means it runs well with the cloud. So yeah, so this is typical your, if you look at the traditional architecture, you have hardware, operating system, applications, right? And it's moving to, okay, you have hardware, and then you have virtualization layer, and then you have your operating system. I mean, you have 3 different operating system, and then the applications. So what happened in the last 5 years? So with the concept of virtualization, you can get more juice out of the same resource, right? Remember we talked about multi-tenancy. Now 2 people are sharing the same computer, or even 3 people, or more 10. Now think about large computer system. It could be 10 people using the same computer, but they may not be aware of it. They think they own the resources, right? So this is resource isolation. And the last, you have standardization portability. Portability is because you follow standardization, so whatever works here, it works everywhere. And then the container revolution came along, control groups and network namespaces. So control groups and network namespaces allow you to get the kind of isolation that you need at the network layer and at the compute layer and the process layer. Yeah, portability and cloud native that we just talked about. So what is containerization analogy? Now you must have seen this ship on your left. Look at those boxes. I mean, they are called containers in shipping terminology. But the consistent thing is that the same thing gets lifted up and put on a train. Nobody should worry about, well, would it fit in? Would it go under the bridge? I mean, all those questions are mute at this point, right? And again, the same thing, once it goes to the roadways, it just sits on a truck. Now again, does it fit in? So once you have these standards defined, right, all you need to do is make sure it fits your standards and put stuff whatever you want in it. Now, what does this actually help you achieve? It actually helps you achieve portability, right? So when you think about containers, largely it's portable. And it's, now, another thing is the speed, right? Now you want to take this container from one place to another place. You can take it the cheapest way and then the quickest way and so on. Before this, in the shipping industry, before this came along, it was so difficult because of lack of standardization. I mean, you have like different kinds of trucks, and then the equipment arrives, it doesn't fit into the truck, and so on and so forth. Now, same thing is happening in the computer industry. What we call containers and Kubernetes. We'll talk about it. Now, containers are lightweight, isolated operating system processes running on a host. Now, unlike virtual machines, right? Containers doesn't need a hypervisor. Remember when we talked about early virtualization, you needed hypervisor. But what happened? What happened to the hypervisor? So some of the features that were part of hypervisors, right? They got into the operating system itself. Like Linux, for example, it already has some hypervisor features. And even the integrated chips made by Intel and AMD, they are enabled for virtualization. So they are also doing some of the work. So hypervisors are becoming thinner and thinner. All containers on the node share the same operating system. Okay. So some of you, these containers could be challenging to understand, but just enjoy the lecture because we will cover this in greater detail later on. So all containers share the same OS. So they are essentially processes that achieve strong isolation using kernel features. You have control groups, namespaces, and network namespaces. Now, containers are packaged as an image. So whenever you think of container, you think of it as an image. Sometimes they have multiple layers. So right now, you don't have to worry about what multiple layer is, but just remember that an image would have multiple layers. Provides increased portability. So remember that we talked about portability. A container registry that serves as a repo for your images. Now, back in the days, 10 years back, it was this case where, the software works on my machine but doesn't work on other machine. Okay, so all those things are passe because when you think of containers, it's all self-packaged. It has got everything that it needs. So Kubernetes. So when you think of containers, you definitely have to talk about Kubernetes because Kubernetes is the orchestration engine from Google, and it automates computer application deployment, scaling, and management. It's highly agile and extensible. Think of Kubernetes as like the kind of an operating system for containers, although that definition is not right, but it's getting there. It's like more like an application container. It does everything what the containers need. Okay? And it's very fast. Okay, and that's the reason it's popular. And containers are fast, so Kubernetes knows how to manage this, how to bring them up, how to monitor them, and what happens if the container is dying or getting error state. Everything is managed by Kubernetes. Now, horizontal and vertical scalability. Now, that is one thing that came up very recent. I mean, horizontal scalability came up recently, but think about being able to add more resources to the container or bring up more additional containers because you're not able to manage the load. So that's where Kubernetes comes in and it manages all of these for you. Rolling updates with zero downtime. If you remember, again, in the old applications, if you have to upgrade, then you have to tell your customers that, we are going through an upgrade, so services won't be available during middle of the night sometime. But all of them is passe now. You have rolling updates, and with rolling updates, it's possible. So one after another, each container kind of gets upgraded, and the customer actually would have no idea that upgradation is going on. So pretty much, if you think of Kubernetes, the default operating environment on the cloud. In fact, huge number of applications are running on Kubernetes these days. Kubernetes is revolutionizing the infrastructure space. It actually originally started off as PaaS, but whether Kubernetes is platform as service or infrastructure as service, it's somewhere between the two. Okay. Types of cloud. Now, we talked about SaaS, PaaS, and infrastructure service. Now, think about public cloud. Public cloud is what Amazon AWS is. Now, public cloud is a multi-tenant platform that uses standard cloud computing model to make resources such as VMs, applications, or storage available to users remotely. Public cloud services may be free or offered through a variety of subscription or on-demand pricing schemes, including pay per. So, public cloud, Amazon. Now, yes, that's fine. What about private cloud? So, normally, private cloud is a cloud that is installed on premises, like in your company. You can have your own cloud. But again, remember, public cloud is multi-tenant, and private cloud is single tenant always. That is only one tenant is using it, or one business is using it. Okay. Now, types of cloud. Okay. Now, a mix of public and private cloud, which is called hybrid. Now, where does this come from? Like, you want to host some of your resources on your premises and some of your resources in the cloud. But why would you want to do it? But if you want to take advantage of best of both, this is a good option. So your critical secret data that you are worried about privacy, everything will stay on-prem, and maybe your database or not database, like your applications are probably running on the cloud, right? Because that may be cheaper for you. So these two together constitute what we call as hybrid cloud. Now we'll look at some of the top 10 providers. We talked about Amazon AWS. There is Azure, Salesforce, Rackspace, Alibaba. Now Amazon AWS is the biggest. It provides very high, there's a high penetration in the market, and Amazon reports 45 billion annual AWS revenue. So you can imagine that Amazon alone generates close to 50 billion, because by the time this is like a couple of months old, but right now it could be touching 50 billion annual revenue. So if you see the amount of services Amazon provides, I mean, it's huge. So Azure, Microsoft Azure is the largest, second largest, and it's growing pretty fast. I think from what I understand, Azure generates more revenue than AWS on the cloud per se, but Microsoft doesn't reveal the cloud revenue, but that's a belief. Now, Google Cloud is the third largest provider, but is the fastest growing. And why I like Google Cloud over other thing is because the Google Cloud platform is innovating all the time. And if you think about AI tools, which are in fact getting a lot more popular these days, they are the cutting edge. Google's tools are at the cutting edge of cloud technologies. Now we talked about briefly. During the agenda we wanted to look at the future trends, right? In the cloud technologies. So you must have heard about server microservices. Now, why microservices has become important is because you want agility in your application, rapid design and deployment of your services. So the microservices is the newer kind of architecture where your application is split up into smaller services that can run independently, and they're loosely coupled, and they all run in containers. Now, this gives you additional flexibility in scaling individual services. If you recall the old days when you want to get an additional web server, right? I mean, you need to install another machine and then get everything all the web services needs. Okay, so that's like duplicating effort sometimes, and then unnecessarily using resources for which you don't need to commit any resources. But now when you split your applications, which is called a monolith, the word that is used is called monolith. When you split into microservices, you have smaller services, and now you can individually scale them. Now, previously you had to scale the whole thing. Now, you don't have to do that. You can scale individual services. Okay. Yeah. So that's microservices, a new future trend, and now the serverless. Now, those of you who have heard of Lambda function as a service, serverless actually means that only when there is an activity you have a server running. Otherwise, no. A good example would be like this passport application center, right? There's a service called check status. You enter your whatever reference number, and then it will tell you whether the passport is ready or like it is in process. Now think about that in the middle of the night from 11 a.m. to 4 a.m. or 5 a.m. Nobody actually is checking for passport service, right? Nobody is checking. So imagine if, assuming your passport service is a container, then there's no request, right? It'll just die. And in the morning, when the first request comes, somebody is sending a request, then the first time your container starts up, and because it's the first time, it may take a couple of seconds start up, and then it will give you an answer. okay, your passport is available or not available. And then as throughout the day, as more people keep checking, right, one container may not be enough, so it launch more containers. Okay, so it is that dynamic. So the way Amazon or Google would build these services, instead of billing for 24 hours, they'll only bill you for 18 hours, because only for 18 hours your service was running, because there were no customers. So we are going that flexible in terms of usage. Now without serverless, what happens is, right, you're renting this machine, and that machine is up and running 24 hours. You probably don't need it for 24 hours. You may need it for 18 hours. So that's what serverless will bring. Now, whatever example I gave, it's very simplistic, but in real life, you can see that the way it scales, like when there's no demand, the resources shrink, and there's a lot more demand, the resources expand quickly. Okay. Now, multi-cloud and hybrid clouds. We touched upon multi-cloud and hybrid cloud, like spreading your resources across on-prem and on the cloud, and take advantage of the best of what is available by the private cloud and the public cloud. Edge computing. So edge computing is a new thing that we keep hearing these days. So essentially, remember we talked about Google having 20, 30 regions and so on. Now with edge computing, the machine the compute resources are shifting close to the source. For example, think about, I think the use case here would be the IoT. Now, before edge computing, what used to happen is IoT used to pick up those signals or the information and then pass it on all the way to the cloud. And sometimes your cloud is way away, right? And then there's huge amount of data getting transferred. Instead, your compute resources are moving closer to where your IoT device is. Now, there is no need for a compute device to be available for every IoT device, but a cluster of IoT device would be served by an edge computing device, and then this edge computing device would do the processing whatever is required and send only that data to the region. So when you think of edge computing, it's about compute resources coming closer to the source of the data. Okay. Now, now remember that concept of virtual machines being replaced by containers. Now there's other technologies that says, both VMs and containers can coexist together. Now why is this important? Now you always, these enterprises always were always looking to move their applications onto containers, but there are some applications that are still running on VMs. They're difficult to move, and sometimes the businesses have committed a lot of resources already to running them on virtual machines. So then they don't really, they want to realize all the investments they want on the VM. So they want to keep the VMs also. But how do you manage these two together? That's where the cube word comes. And then the new things, DevSecOps. So you must have heard about DevOps, development operations. Now the next step is DevSecOps. Essentially introduce a security component into DevOps. So it's about security from the start, from the time you build your image to deployment, building and deployment. So build, deploy, build, test, deploy. So enabling security across is what DevSecOps is. Okay, so I think we are talking about enough about cloud technologies. Now, the employment potential. Now, you should remember that cloud technologies are expanding. Although, the world over, there's 120 billion, 140 billion revenue, cloud revenue. But remember that there's still a lot of applications that are still not in the cloud. At some point, all of these companies would move their data into the cloud. So what does this mean? Cloud is expanding, so which means what? There is a need for talent. So there is a talent shortage in cloud technologies. One thing is because cloud technologies are always evolving. The new things are always coming up. You want to catch up. Okay, so there is a shortage, and again, huge employment potential because there is shortage of technology specialists. And then something to help you out is there are plenty of resources available for learning, right? Now, when you think about I want to learn Google or I want to learn Amazon, right? There are plenty of resources available. Now, Google gives you free $300 in GCP resources for free. Earlier, they used to keep this $300 for 1 year. Now you have to consume them in 6 months. So that's the only thing. Now, with $300, right, credit, you can do a lot on GCP platform. Okay, and then you also have Amazon AWS that's giving away plenty of free training material and resources. Same. There's no cash amount, but they will give you free training and material and resources. Now, similarly, Microsoft Azure does the same thing. Gives you $200 worth of resources to start with. And then you have Google's Quick Labs. That will give you plenty of free training material. Okay, I think that's all for today's presentation. If you guys have any questions, please do let me know. You can type it here in the chat, and then soon after that we will talk. I want to talk to each one of you individually.
Yeah. Thank you, Rama. You're on time, and you have covered pretty much all the things to set the foundation. So quickly, I'm going to stop the live streaming here because the next session does not need to be recorded. Okay.